All right, just a review from one of the earlier videos. We are going to be talking about rate of change. Rate of change, remember, is a ratio. Ratio means we're dealing with a type of fraction that compares two things. The first thing is what goes on the top part of the fraction. The second thing is what goes on the bottom part of the fraction. And how they know, first, after the word compares, they tell you what goes on the top part of the fraction, and then they'll say the word to, T-O, and then after the word to is to what tells you what goes on the bottom part of the fraction. So let's go ahead and let's talk about this. A rate of change is a ratio that compares the amount of change in the dependent variable to, so dependent is going on top, so rate of change, change in the dependent variable to the amount of change in the independent variable, which is right here. Now, the dependent variable, that is the y. Remember, we talked about this triangle being the change. So it's a change in y, and the change in the independent variable is the x, that is over the change of x. And the rate of change is really the same thing as the slope. So the rates for a set of data may vary, or they may be constant. And if they are constant, then that means that we are dealing with a linear equation. All right. So in this particular example, oh wait, we're not doing the check it out one yet. We are doing this example and then the check it out. Okay, so example 2a, it says identify constant and variable rates of change in data. So we are going to determine whether the rates of change are constant or variable. And to do that, we're going to find the differences between the consecutive data points. So I am sorry, but I have to break out the glitter. It needs to be done. I need a little bit of glitter in my life, so it's going to happen. We are going to start with the purple glitter. So we are just going to look at the changes between the x changes between here, between 0 and 1. And 0 and 1, what's happening is we are adding 1. Oh yes, we are adding 1 with the purple glitter, and that feels pretty good. Okay, we're going to move on. Now, what's the change going from 1 to 3? Well, from 1 to 3, we are adding 2. And this is the pink glitter. And oh, it is so pretty. There we go. And then, what is happening from 3 to 5? Well, from 3 to 5, we are, it's 3 plus 2, and that's how we get 5. And we are breaking out the green glitter. And I really like that one. That one is very electric. And then lastly, from 5 to 8, the difference is, it would be 5 plus 3 equals 8. So there we go. We'll be adding 3. All right. Well, just by looking at it, you know, there's some variation, 1 plus 2 plus 3. But let's go ahead and look at the y values. So we would just look at this and be like, oh, they're different, so it's not a linear equation. Well, it's not always the case, and I'm going to show you here in one of these two examples. So let's go ahead and look at this right here. Okay, so we're looking at this. Okay, so what's happening in the y variables from 0 to 2? Well, we're adding 2. Okay. What's happening between 2 and 6? Well, we're adding 4. Okay. And then what is happening from 6 to 10? Well, we're going 6 plus 4 equals 10. And goodness gracious, that green looks amazing. Okay. It looks so good. I think it looks good too. Oh, thank you, Pause Dragon. I know it looks good. Okay, on to the blue. What is happening from 10 to 6? Well, from 10 to 6, it is 10 plus 6. And that's how you get 16. Perfect, perfect, perfect. Okay. So what we're going to do is we're going to find each ratio of change from y to x. So we are going to put the y over the x, just like the equation is the change in y, the rate of change is the change in y over the change in x. So here in purple, we're going to look at this relationship. We're going to go the change in y from the y variables is equal to 2 over the change in x is 1. Well, 2 over 1 is just 2, right? All right. So that is the first rate of change between these 2 points. It's 2. Okay, let's look at the next two. The rate of change is the y over the change in x. And the change in the y variable from these 2 points is the y change is 4 over the change in x is 2. And what's 4 divided by 2? That is equal to 2. Now look at that. Isn't that interesting? This rate of change is 2, and also this rate of change is also 2, even though it doesn't appear like the rate of change is the same. But in actuality, these are the same. Okay, let's look at the next one. Let's look at the rate of change y over the change in x. So from these 2 points here, the rate of change for the y is actually 4, and the rate of change for the x's is 2. What's 4 divided by 2? Well, it is 2 again, and oh my goodness. This is also the same. They so far have the same amount, the same rate of change, which would imply that they are, this is a linear relationship. It doesn't look like a linear relationship, but it totally is a linear relationship. Okay, let's do the last one. The change in y over the change in x. The change in y is 6 over the change in x is 3. I feel like this glitter pen is failing me right now. I need you to work, glitter pen. So it's 6 over 3. And what is 6 divided by 3? It is 2 as well. Okay? Since the rate of change is constant, since the rate, and this is my black glitter pen, I kind of like this one a lot too. Since the rate of change is constant, constant means it's the same, the table, which is this right up here, shows linear, which is a line, data. Awesome, awesome. I think it needs a little bit of black sparkly cloud around it. Okay, there we go. And that is that problem. Let's go on to 2B. We're going to do the same thing. We're going to look at the relationship between these different ordered pairs or solutions. So, here, we're going to look at, okay, what's happening from 1 to 3? Well, you're going 1 plus 2 and getting 3, okay? What about from 3 to 4? Well, here, we are adding 1. Okay, and then what about from 4 to 6? Well, 4 plus 2 is 6. And what about from 6 to 9? Well, 6 plus 3 is 9. All right, so those are the changes of x, the independent variable. Let's look at y, the dependent variable. So what is happening from 0 to 2? Well, they're going 0 plus 2 equals 2. And what about from 2 to 6? Well, 2 plus 4 equals 6. And what about from 6 to 6? Oh, well, that's not really changing at all, right? So that would just be plus 0. Huh. Okay. And then what's happening from 6 to 3? Well, this is not increasing, so it's not plus. It's actually decreasing, so that's actually, it's subtracting 3. Well, now this, we haven't seen one like this before. But let's go ahead and calculate the rate of changes and actually see what's going on. So first, let's find the rate of change of the rate of change equals the change in y over the change in x. So let's see here. The change in y is 2 over the change in x is 2, which is 1. Okay, so that means the rate of change is 1. Let's do the next one. The rate of change of y y, or the change in y over the change of x, is the change in y between those is 4, and the change in x is 1. So the rate of change is actually 4. Well, those aren't the same as at all. We have 4 here, and we have 1 there. So right now, we know that this is not a linear relationship, because for a relationship to be linear, we need all of these relationships, all of the rate of changes to be the same thing, like 2, 2, 2, 2. They're all the same. That means the rate of change is constant, and that means that it shows linear data. So right here, the rate of changes are not constant. They're not the same. This is 1 and that's 4. At this point, we could just say, hey, this is not a linear relationship, but let's go ahead and keep going and just finish the problem through. So change in y over the change of x, because I'm just kind of curious about the 0. So it says the rate of change is 0, so that's going to be 0 over the change in x is 2. So 0 over 2 is just 0. Okay. So far we have 3 different rate of changes. Let's see what happens with the last one. The change in y over the change in x, which is the change in y is a negative 3 over a positive 3, which is actually equal to negative 3 divided by 3 would be a negative 1. Well, there you have it. There are 4 different rates of change. What that means is that the rates of change are variable. That means they're changing. They're not the same. Varies means that they're all different. This table up here shows non-linear data. And non-linear means it's not, linear means a line, so it's not a line. So it's data that is not a line, which is exactly what this is. That data is definitely not a line. Oh, that was kind of a fun little cloud there. All right, so now it is your turn to show me what you got. Here we go. Check it out. Example 2A. So you're going to do 2A and 2B, just like we just did. And now it is time for our friend, the lovely Pause Dragon. And where is he at? Pause Dragon, where are you? Where are you? Where are you? Here I am. Here I am. So go ahead and pause your electronic device and solve these problems and come back in a little bit and we will talk about it. All right, see you in a bit. Bye. You can do it. Okay, we are back. Let's go ahead and figure out this problem. So we're looking at the rate, the difference between the consecutive data points. So from 0 to 1, that is a +1. From 1 to 2, that is a also 1 plus 1. That's how you get 2. From 2 to 3, you add 1 every single time. And from 3 to 4, you add 1 again. All right, that looks like a constant. Let's go ahead and look at the bottom. So what's happening here? From 1 to 3, we're going 1 plus 2 and getting 3. From 3 to 5, we're going 3 plus 2 and we're getting 5. From 5 to 7, we are getting 5 plus 2 and getting 7. And then from 7 to 11, we are going 7 plus 4 to get 11. 7 plus 4 is 11. Yes. Okay, so let's go ahead and talk about the rates of change. So where is my lovely purple? Here it is, my purple sparkly. So the change in y over the change in x. So here we go. The change in y is 2 over 1. Okay, which is 2 divided by 1 is 2. Okay. And then the next one is going to be the change in y over the change in x. And the change in y is 2 over 1, which is 2. Awesome! That means that both of these are the same. That's exactly what we need, but we need it to be the same for all.